Hi science students, in this video we're going to begin discussing force. Now there are different forces that are acting in different situations. If we have a look at this animation here, we have the robot moving company. This robot is going to move this box for us in a moment. But first, I just want to discuss the forces that are acting on this box. We have this force in the downwards direction called Fg. That's force due to gravity. So this box has a mass, and that mass is being acted on by a gravitational force which gives it a weight. So sometimes you'll see F with a subscript W instead of Fg. So we can call that Fg or Fw. Now, equal in magnitude but opposite in direction, we have a normal force, and that's balanced with the force due to gravity, and that is the floor pushing back up on the box. So if the floor was not very strong, the box might fall through the floor, and in that case the gravity force due to gravity would be greater than the force, the normal force that's acting back upwards. Now right now these forces are equal and opposite, so they're balancing one another. So the box isn't moving. If we get the robot to push on the box and we overcome the force of friction, we see we have an unbalanced force and the box moves. If I push this way and push the box for a bit, once again, eventually friction, that unbalanced force acting in that opposite direction, will slow the box down to zero again. If we were to do this on ice and I push that box, the box will just keep moving at that constant velocity because there's no unbalanced force acting in the opposite direction now. That's a frictionless surface. Okay, so let's look at these force diagrams and start discussing this net force that may be acting on an object. So in this first one here, we've got 7 newtons in this direction and 7 newtons in this direction. So those forces balance one another. If we top to tail those vectors, we have the 7 newtons this way and the 7 newtons that way. So if a body was to start here, it'd be pushed in one direction and then in the other, and it would not move because those forces are balanced. So the net force is equal to 0. However, this example here, the forces are unbalanced, so the net force is going to be greater than 0, and this object will move. Now, here we've got 7 newtons to the right and 2 newtons to the left. I'm going to set right as positive. So 7 plus negative 2, because this 2 newtons is in the negative direction to the left, means we have a net force of 5 newtons to the right. So that is our net force, F net. Okay, I'm going to let you guys go ahead and try these examples. This first one's similar, but forces acting upwards and downwards. They get a little bit more complicated. We're going to need to use some Pythagoras for these ones. See if you can work them out, and you can check the solutions in the notes that I've posted on Canvas.